Okay, folks, so we're going to continue on and talk about some three new topics when dealing with exceptions. And the topics are the finally clause. So we're going to add on uh, to our try catch statement with a finally clause. We're going to introduce the stack trace and elaborate on what is the stack trace and how it can help us. And then we're going to talk about uncaught exceptions. So let's jump right in. And I'm going to put a couple lines of code here inside of our try and a catch, and finally comes after the catch block. And so the theory behind the finally is that the finally clause will run after the try, whether the try triggers an exception or not. So if the try runs and triggers an exception, then it'll run the catch block and then the finally block. Or if the try block runs and does not trigger an exception, it'll skip the catch block and it will run the finally block. And so the typical question I get, so actually let me jot this down. Always executed after the try block has executed, and after any catch blocks have executed, if an exception was thrown. So that's when the finally clause runs. And I got a really great question one time, and a student says, hey, doesn't any code after a catch block run under those same conditions? And that kind of got me thinking a little bit, and he asked a really good question, and it stumped me for a little bit. I had to go back in and look into it, but the answer was actually no. Um, and here's when the finally block would run when otherwise it would not have run. Okay, so you got the theory behind the finally block and when it runs, but here's when the finally block would really come in use. Okay, when otherwise this code wouldn't have run. So let me go ahead and do a. I'm going to open up a file here. Like we're going to write to a file, and then I'm going to call it my.txt. And I'm also going to do an arithmetic exception. So there's two potential exceptions here. One from working with a file, like file not found exception, and an arithmetic exception from dividing by 0. I'm going to catch the arithmetic. And so the arithmetic exception would be caught. And you could see if I do not catch the file not found exception, so one solution is catch. And that would take care of that. But let's say we don't catch that file not found exception. This is where the finally block would come into play. And we just say throws IO exception. And that just, I can't type IO exception. And so here's a scenario where we open a file and maybe we write to a file. But there's always three steps, right? You open a file, you write to a file, and then you close the file. So we're going to put the close. Actually, it's not in scope if I create it this way. So let me go ahead and create the print writer outside and open it inside of the try. That way PW is in scope. Well, so if this were to run and throw a file not found exception, It's saying it might not have been initialized. So the fix to that, well, a quick fix anyways, we'll just initialize it to null initially. That'll satisfy the compiler. So here's a scenario where an exception could be thrown and we don't have a catch block to handle that exception, yet we're still, regardless here, the program is crashing, okay? And on its way out, before it completely crashes, right? So the try block executed, it threw an exception. And before it crashes, this finally block will run. So we will close our connection to that file. And maybe that helps commit any changes to that file that were made, or maybe we close a connection to a database and things like that. So that's the scenario where the finally really comes into use, when you're closing your connections or you're performing cleanup tasks that maybe an exception is out there, you didn't catch it properly, and you want to make sure that you clean up perform your cleanup tasks like closing connections to files or databases. And so that's when finally is really useful. So moving on, the stack trace. And to do this, I'm going to make a couple methods here. I'll just call them public static void method A, method B, just to demonstrate the stack trace. Because what the stack trace is the list of methods that have been called, and it's used to help troubleshoot the sequence of events before an exception occurred. When I say the sequence of events, the methods that are calling one another. So if you have, maybe we'll say method C, and method C is actually going to cause our exception. Well, how did method C even get called? Well, if we examine the stack trace, we'll be able to tell that the main method called method A, which called B, which called C, and C threw the exception. And to actually make the method calls here, method B, method C. And so you could see here, I'm going to go ahead and comment out my prior code. And to demonstrate the stack trace, I just have to call method A. Again, so here we're calling A calling B calling C, and C throwing the exception. So if I run this, essentially here we're seeing a little bit of the stack trace, in which main calls A calls B calls C, and then so in C we're trying to divide by 0. Now let me put that system out, print line back in. Now there is a method called print stack trace that if we wanted to put this in a try and catch, and just to demonstrate this is being caught properly, we say hello, so this exception is being caught. There is a way to use the exception object and print the stack trace, and it's going to look very similar to what we just saw. So there is a print stack trace method which produces the same output or similar output as just the exception occurring. maybe a little bit less information, but basically it is the stack trace. Which brings us to our final topic, which is uncaught exceptions. So if we left this uncaught, what happens? What's the flow? Well, so when an exception occurs, the first thing it does is it looks in the current method to see if there's a handler, if there's a try catch. So if the exception happens in method C, it's looking for a catch clause in method C to handle it. And we could implement that. Try catch arithmetic exception EX, and then and if it can be caught inside of that method, then that's fine, and the program will continue executing. However, what happens if the try and catch is not? Right, so the exception is still going to occur inside of method C, but we're not catching it in method C. So what will happen is actually the exception will bubble up, right? So it'll bubble up to the previous method inside of method B, and we can actually catch the exception inside of method B. Can't type. Okay, I had a typo there. Arithmetic exception, yes. And you could see we can catch it here. And so it bubbles up. The exception happens in C, but it bubbles up to B, and we catch it there. And you can see the exception was caught. However, maybe we don't want to catch it in B, right? B calls C. We could catch it in A, and we know A calls B. So we try and catch, and now we would catch the exception as A. And as you might guess, it can bubble all the way back up to the main method. So if we take the catch block out of A and have A just call method B, we could put it here, call method A, and so the exception could happen in C, but then we don't catch it all the way until back in the main method. Now that is what is recommended practice or best practice. You can write the methods, and the methods may cause exceptions. However, you want to let the person using your classes decide how they want to handle those exceptions. If they want to use try catches, or so there are many scenarios where you will let the exception bubble up the call stack, bubble up from C to B to A, and then determine if you want to try and catch the exception when you're using the class or not. And so that is how uncaught exceptions work. Now, the last part of that, what happens if you decide not to catch it, right? So an exception occurs, we do not catch it whatsoever. Then what's called the default exception handler runs, which is what you've seen before. This is the default exception handler. And so if it bubbles all the way up to the main method doesn't handle the exception gets passed to the default exception handler, which essentially crashes your program and gives you the following output. So that's what happens if it goes all the way up to the main method and doesn't get caught. Okay, so that's the end of the topics here: the finally clause, the stack trace, and uncaught exceptions.